Hi everyone, we'll be waiting 2 to 3 minutes before starting the webinar to accommodate for the rest of the attendees who are in the middle of connecting. Welcome everyone. Thanks for joining us and thanks for being part of our community. My name is Valen Kolika and I'll be your host for today. Just a few reminders before we kick off with this webinar. If you have issues viewing the stream at any time during the presentation and are using the web browser version of Teams, please refresh your browser. If you're using the desktop app of Teams, please exit and rejoin. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. Closed captions in several languages are available during the live broadcast, and you can enable that by clicking on the CC button located at the lower right corner of your screen. Feel free to ask questions at any time by typing them in live Q&A window by clicking on the Ask a Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. We often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event, if the answer was not provided, or if you may have additional questions post this event, please don't hesitate to raise them on our Azure Compute forum at aka.ms/Azure Compute Community. If you're listening to this after the fact as a recording, that's also a great place to ask a question. We'd love to hear your feedback on how we can improve on these webinars, and you can do so at aka.ms/security-webinar-feedback. If I would also like to invite you to join our public community by visiting aka.ms/security community. That's the best way to ensure that you don't miss any future webinars or major announcements. Now, on our community, you can speak directly to our engineering teams that create our security products. and you'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, which you can sign up at aka.ms/securityprp. You can request features, give feedback, review our product roadmaps, register for events, or join webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Amar Goda will take us through Azure Confidential Computing nodes for Azure Kubernetes Service. Amar is a senior program manager with Azure Compute team, and without further ado, I will turn it over to him. Amar, the floor is yours.
Thank you, Weldon. Hi, everyone. My name is Amar Gowda. I'm one of the product managers who's leading the effort for container compute in Azure Confidential Computing. I'm really happy to be here and share some amazing things we have done in this space that can enable a lot of scenarios and bring the additional layer of security you have always asked for. Without further ado, this is what I plan to cover. The approach this time I'm planning to take is basically answer the basic questions you always have, like why do I need this? How does this work? What are the concepts I need to know? And what are the scenarios the customers are trying to solve? And a quick demo of what this may look like from a developer side and from the operator side. What are these delta, the additional things you may have to do? All of this is in the cloud native space, so I'm really excited to share some things here. Okay, so why confidential containers? This is a great addition to your defense in depth container strategy. We all know containers have become the norm across the industry. Everything is now being containerized, and most of the workloads end up on Kubernetes as an orchestrator. So the zero trust security modeling is kind of becoming a norm these days, and how you add layers of security to protect the data in use, as well as the access control, who can do changes in the space of orchestrators like Kubernetes. So in the right side of the picture, you see how containers and what are the important things I want to cover in the surface attack area, or the surface area where we protect through confidential containers. That could be data confidentiality, integrity of that data in memory, the code integrity, right? Once it's loaded, what's the guarantee that it is the code that was loaded and not tampered with? And it's also attaching to the hardware root of trust. Right? All of these add to another layer of security that you may take advantage of. This could also be very true on how to meet some regulations and some confidentiality regulations, internal as well as external regulations you may have for running container workloads. Okay, so let's explore some attack areas where this topic is relevant today, right? So you have this multiple layers in Kubernetes, right? Starting from the nodes, you have your subject container, which is the one you probably want to protect. And the containers around it, they're all the containers you pack a lot more in one node. And you have a layer above, which is hypervisor layer, and a layer above, which is a host OS layer that is running your level 0 hypervisors. So if I break this down, so we look at this as, here is your first vector, right? This is in-memory attacks. Here's your second layer. Here's your third, right? So now so let's not forget. So you have your own apps that are sharing the same host that's also trying to do something to pull the information out from the subject container. So all of this is where we come in, and we can bring that additional layer that is needed to abstract this away. So let's look at just the general trust boundary in the space of cloud, right? So you have multiple services like SaaS, PaaS, and IaaS offerings. There's physical access to data centers. You have hypervisor administrators. You have cloud administrators. You also have your own guest OS administrators, right? It could be an operator, Or you could be using a third-party managed service company who's keeping the lights on your Kubernetes cluster or your virtual machine. All of these are different layers of trust you need to put in and make sure nothing is going wrong, and the code that is running is authorized and the memory is protected. So this is today, right? So we all know, right? At data at rest, we use keys for encrypting. In data in transit, we use TLS 1.2, 1.1. These have become the industry norm and standards. Right? This is the data protection space today. So the third one that we are trying to bring is the data in use protection. So this was another big vector that was not explored until now. And this is like the final leg in your three-legged stool approach, right? So you add all of these, you have a good place to start with on the security and the protection of the data, right? This could be any sensitive data, or it could be general, like a standard way of doing the things. All right, so let's put up all these things together and how we want to evolve from, our mission is to evolve from computing in clear to computing confidentially, right? So that's why we always believe in building more layer of services that are required to secure our applications. So this is data encryption in data in use that is encrypted. There are numerous concepts that I will go over. For example, like attestation. Attestation are two layers, attestation of the hardware and software. Our current offerings are all based on hardware root of trust that, hey, Microsoft is off the hands and you trust the hardware and you trust your app you're running, right? So that's how we keep our hands off on anything in the space when your application is running. So to do this, right, so we were one of the founding members of the Confidential Computing Consortium. This consortium is helping bring kind of standards and evolve the industry from computing in clear to computing confidentially. The list of companies who have joined this is a short list. There's much more growing. There's a lot of investment here and a lot of innovation that is happening from the OSS community, as well as ISVs and partners and large organizations who all believe this is where we should be, right? And how to build confidential apps and take advantage of the technology here. All right, so I made a case as why it is important for your defense in depth for your container security. Let's go to the how part of it. But how does this work? What is this? All right, so think of it this way, right? So this is based on SGX, Intel SGX based offerings. This is the diagram I'm going to walk you through. The challenges you always run into is enclave when you load an application in your memory, inside the memory, it's all in plain text. For anybody outside looking at it, it's still a plain text, right? So that's the boundary we put. There could be plenty of things. It could be your key generation. You could be using for doing some crypto operations like tokenizing and input, or just a PII information you may be dealing with. So how does the flow work in your application? So an enclave is a special reserved space, an isolated reserved space for your memory to be fully encrypted for anyone outside of it for protections. And the second part of it is it can have an untrusted and a trusted part of it, right? You get full control on, hey, now in my application, I want to start an enclave and perform computing confidentially. And once I'm done, I'm going to kill that enclave, come back and process normally I need to do, right? That's the way untrusted and trusted boundaries are created. So once this process launches in an enclave, there is a special part of the memory it uses and it loads all of the data there. When it loads, it also measures what am I expected to load? What are my BIOS versions? Is my root of trust going back to Intel? So all of that are part of the attestation concepts. They all get checked before an enclave is fully launched and is ready to process your applications. So once it's done, then it returns whatever the values it is back to your untrusted part. This is a traditional SGX operating, right? Untrusted and trusted boundaries to this. Okay. So containers, right? Containers work exactly the same way. The only difference with confidential containers is you don't have the untrusted and the trusted part to this. When you launch an confidential container, all binaries of a confidential container will launch in an enclave. So everything in there, any dependencies you have packaged, your base OS you have built your container with, everything is going and launching in an enclave. So and you're using the EPC memory and you're measuring the whole enclave that has been launched. So we now support this on Azure Kubernetes Service. I have specific slides that goes over some features we have built that should help you and make you feel very natural how you're using Kubernetes and cloud native practices. So there are plenty of applications, and I'm going to go over in the next part where we have seen a lot of traction in this area from the time we went preview on the service. Okay, so here are some typical use cases for confidential computing. Right, this is a start, and we have plenty more we could go in detail with. I want to highlight some things in the space of cloud native and Kubernetes container workloads. Privacy preserving analytics. This is about how do you bring multiple parties together to compute securely with their data and their code. Okay, so the code part is super important here. If I'm a party, I know I have an ML model, trained model. I want to bring that to you to compute, but I want to get assurances that the code is protected and the data is fully protected, and the keys that are used for decrypting my confidential data is fully protected and is only released to this instance that it should be. Right? There are multiple layers, and I'm going to walk you through an example of how a couple of my companies are trying to do this. So let's go to the next one here, which is the payment processing. In the financial industry, it's very typical. You always deal with PII information or anything that is regulatory and compliance related. This is where we see a lot of traction. We know how Kubernetes has become the approved platform in financial industries. And this is adding a great value in the same space to take your existing apps, existing container apps, and run them confidentially. So that's the payment processing part, right? It could be like tokenization of a credit card number that is you're submitting it through an REST API, or it could be something where you're doing data crunching, but this is like a plain text account information, or could be like money laundering type of use cases. Blockchain ledgers is another space which is very prevailing because of the key generation that is required, right? So you have to stitch a multiple set of keys before you put a transaction, and where the keys are generated, these are generated in an enclave. So this is another space we see a lot of traction because this is a secluded space that nobody has access to other than the app itself, which has called into an enclave. So this is a good use case. Key management, right? Think of it this way, right? You have keys or certificates. You need to pull them down from an Azure Key Vault or from other KMS services, and you want to cache it, but cache it securely so your apps can interact with it, and it's not open for any guest admin to go and look into. This is where we see a lot more use cases and some ISVs who have built solutions on top of this. And our own Azure Key Vault MHSM is backed by Azure Confidential Computing hardware. We use the same hardware for MHSM keys. Another space is in-memory databases. All right, so Redis and SQL Memcache, SQLite. So there are a few of them which we continue to see are kind of prevailingly being used in this space, at least in the containers. Let me walk you through this scenario I was mentioning. So here is one way to look at this, right? A party, like a first party, hosting party, is saying, I'm building a platform on AKS. I want to invite party A, B, and C, or a collaborated party. I may be a retail company, I may be a manufacturing, and asking them to bring their containerized code and the sensitive data they want to bring for computation. Nobody can see no one else's data. Only the computation is performed in this confidential containers platform, right? End of the day, there is output. So rich data in, rich data out, and everybody can benefit from it, but never losing the privacy and the confidentiality of the data. This is a very kind of a hero scenario we continue to see. This is kind of breaking the boundaries for collaboration, right? Before it was like, oh, this is PII, I have to redact a lot of things, I cannot share this. And now this is enabling. Okay, I'm not saying that's you don't have to do any of that, but this is allowing you a step forward from the technology side, how the protections are happening. The good thing here is you can mix the workloads. You can run confidential containers and regular containers next to each other, and the heterogeneous mode is fully supported. We completely understand not every application needs to run confidentially. There are going to be parts of it that may run on the same cluster, and we allow you that with hardware-based isolation so that you don't mix up the boundaries. Okay. Another use case, we did a demo on this a few months back, and we have an open sample out here. We used a partner called Scone to achieve this. So here are these different parties, right? Very typical in the COVID situation we are in. There's a hospital who has trust issues with their partners, like diagnostics provider, for example, here has a trained ML model that will take in your chest X-rays or your brain MRI X-rays and give you a probability score of if this patient is probable for, is a COVID positive, negative, and this is a probability score on this person having brain tumors or not. But that model is so sensitive that Fabricam want to host it themselves, but make sure they are relying that trust back and telling the client, hey, before you submit any data to me, you can attest me. You can check the software and the hardware components and the hash values, all of that together before you transmit data. So that's why you see number 3 here is how a client application is doing attestation before the data is transmitted. So good use case, and I'll leave a link at the end of this to look into more. Right, this is another scenario. Okay, so then we'll go into the plumbing part to this, right? So how does this work? How do I get started? What are my options here? So we have 2 application programming models. Okay, if you want the most control, as I showed you, the untrusted and the trusted parts to the application, you can choose plenty of SDKs, starting from OpenEnclave SDKs, which from Microsoft we backed that open source project to manage that. Right, it's limited to C++, but there are others that you could use, HLSRT with Rust-based programming. You could have a full control. End of the day, you could still build a container, but you have full control. But you have to. It's good for your greenfield type of applications. But we also understand there are plenty of existing apps that are already containerized. How do I bring that? That's why we call it as in quotes lift and shift. Right, for lift and shift, there are plenty of options here. This is one list where you have open source like Graphene, Edgeless, and Oclum. You can take this, and I'll show you what the flow for a developer would mean when you go this path. And I'm going to specifically cover the fastest path, which I call as confidential containers path here. You have ISV partners. Everybody has their own amazing offerings and feature-rich things they do to make operators' life easy, your security operations person's life easy, or your developer's life easy. So you have a spectrum of offerings you can choose and look into. Okay, so what do we provide in Azure, right? So here are the things. So we know there's a strong hardware-based isolation we can provide. This requires particular type of nodes or the SKUs on your AKS for this feature to be lit up. Not all general purpose SKUs has the same thing. This is specifically for Azure confidential computing based SKUs that are right now Intel SGX based DCSV2 SKUs. So you can create multiple enclaves on a same node, Every enclave is unique by itself and is fully hardware isolated from any other container that's running out there. So think about this. This can open up new opportunities of, in a way, a multi-tenancy in nodes, which is one space a lot of customers try to solve on Kubernetes. The second bullet point is super critical. Once an enclave is launched, it directly interacts with CPU. So any problems with your host OS layer or your guest OS layer, like your Linux Ubuntu 18.04, the calls don't route through the host. The calls to your kernel and below to your CPU directly open up a channel and work. That's the beauty of SGX, right? So you're removing all the vulnerabilities that may happen in the guest OS. You get per container attestation. So there could be two Conferential containers running next to each other. They both can attest each other, what we call as attested mutual TLS. They could do that within themselves and then perform computation if the attestation goes through. You could also do remote attestations. You have multiple non-conferential and conferential parts of the things running. And they can attest using a third party here, which is Microsoft Azure Attestation Service. And as I called out, we take a very broader community and partner approach. We have OSS projects that help you. There's a plenty of traction in the cloud native space in bringing this hardware-based isolation and things around conferential computing into the practices of cloud native. Could be OCI and OCI spec and more places around that. For us, we also know some customers believe in flexibility, having full control, and don't like a managed service. For that, we also support AKS Engine. AKS Engine is an open source project where a customer can take this and run it fully on their tenant. They could pick and choose what type of SKU, and their control plane is in full control of you, right? We in the Azure, we don't have to manage your control plane. You have your full control. So I have a few more slides that goes into how this may look like. All right, so how does the flow really look like to me? And I think I went over some of this. On an overall stuff in a high level, if you look at the picture on the top, you have an existing container. You have existing build and release pipelines. Great. That's where it gets injected, right? So this partner ecosystem or OSS, this is the SGX runtime software that is needed for you to run in the SGX. And the rest of the process looks the same. And I'll just walk you through the two roles, like a developer role and operator role, what this flow may look like. Okay. So before we go there, I just wanted to cover a couple more slides how this looks before I jump into the whole flow to this. Here are the different vectors you need to be aware of, and here is how we protect. Encrypted page cache, the EPC memory, is a special memory that is reserved in this machines or virtual machines. That's where your enclaves are launching and using that memory. The rest of the memory, you may have 8 GB or 16 GB. That's a regular memory still available for you to use for your normal apps. For conferential apps, this is the EPC memory. When you go with AKS with conferential computing nodes, you will automatically get SGX decap driver pre-installed for you and FSGS kernel patch that I think it went upstream already. We already put that for these apps to work. So for you, you have to just manage your container app and make sure you are building the container app that is ready to run in an SGX. Right now, we support Linux containers. We are working towards Windows containers, but if you have a need for Windows containers, please leave us feedback or do a +1 in the Q&A if that helps us prioritize the things. One other point, as I called out, we allow heterogeneous node pools, right? The heterogeneous node pool says, hey, I have a GPU node, I have the conferential computing node, and I also have a general purpose node. You can have all of those in the single AKS cluster. So this should make your operator's life easy, right? So this allows you for lowering your costs of managing multiple AKS clusters of different types. And the first point, I think I've told this a couple of times, this is a hardware-based process isolated, right? We check both of those boxes. Okay, so while this thing builds up, let me show you what this eventually looks like, right? You have the AKS cluster. Everything looks normal. There's nothing really different here, right? So you have a VM node, you have the proxy, the kubelets, you have the containerd runtime. All of these are part of it. They're all running in the untrusted part, right? Your containerd, your daemon sets, your CNI, if you're using container insights, for example, all of those services run in the what we call it as untrusted boundary. Once you put in your confidential container and say start your deploy my confidential container, it opens up a special channel. If you look at how the execution is happening, and then directly then the calls go to CPU and you start executing your code, right? And these containers can stay side by side with normal other containers you are running, like as I mentioned. Okay. So let me walk you through. So this is your current life, right? So if you're an application developer, you develop an app, you do some validation testing, functional tests, you containerize the app and you put it in a container registry. You may also be signing that container. I know there's a lot of things happening in the project notary space in this to make sure this is another layer to check before an application or a container is launched. For a DevOps, you choose an orchestrator platform, in this case AKS. You add the necessary nodes, you put some RBAC and some controls and security layer on top, and you just monitor and scale. This is your current life. How would it be different if you go with this? So the real delta here is you need a wrap. You need to wrap your container with the SGX runtime. So depending on which partner you go with, it could be as simple as instead of you building from a standard Alpine base image, you may be building on top of a fine-tuned Alpine SGX base image from a partner, right? Or you could also be doing a Docker multi-build where the SGX software gets added to your core container. And at the launch, right there, you have the start command, right? Start this. We would typically it would be replaced by start an enclave, then load your app.py file, for example. So that's the change, but it's still a container. You could perform the validations and all the tests. You put it in container registry. You can sign it as well if that's the route you're going. Everything applies. And the good part here is there are some partners who also encrypt the container. Okay, this is about encrypting the container itself. So making it kind of blind, right? I know there are a few things that may not work like container scanning and other services, but there are customers who believe there are trained ML models in the container that needs to be protected, right? And that needs to be encrypted before I bring it over to you, a hosting party, for example. So you could go that route. You can fully encrypt the container, and the key release to that could be very specific to where you're running. So the life of a DevOps, what changes? You just add SGX node pools, and we have built an add-on or a plugin that will expose the drivers for you, and another service that helps you do some attestation and quote type of generation. There are two services, as an add-on. It's free of cost, right? It's just an add-on. You don't charge for that. And then you do a monitoring scale. So for a DevOps person, it's just about selecting the node where the containers land. As simple as that. It's a simple Helm change or a YAML change. So this is how we see this evolve, right? This is our current approach we have taken because of SGX itself and how it operates. And I've said that the Intel SGX exposes a special instruction set. That's the way the technology is implemented. That's the reason why we have to wrap SGX runtime software in this case. We ask for developers to perform validation tests so that everything works as expected, and you put it in a container registry and things go as usual. Right, so that was my end of my decks, but I want to kind of quickly jump over to demo. Feel free to ask questions. We may have 5 to 8 minutes at the end to open up for questions as well. All right, so yeah, before I go to demo, I just want to show you how a build from one of our partners looked like, right? This is a typical REST API PI file, and it's just a multi-stage build, and it's building off of and injecting few things, and we start the file like this, right? This is how your Docker file would look like. Okay, so this is pre-recorded, and I will do a voiceover, just letting you all know. So I will start from here. So the context of this demo was, hey, I have an existing REST API Python application built with Flask, which has some NumPy packages and whatnot, and it does some basic math or computation. Very simple demo. We'll get to, in the next set of webinars, get to a real use case and some full end-to-end scenarios. But for this, I just wanted to go to the basics of it. Right. So what would the life of a developer look like here? Right. So as I went through this, you build an SGX ready confidential container, and you deploy the SGX nodes, and you basically go and deploy. Right. End of the day, those are the two operations you may have to perform. OK, so I am here on the portal. Our service is going GA as we speak, so you should have portal access. So right now there is a standard node pool, right? You may have an existing AKS cluster, or you may create a new one. So in this command, what I'm trying to do, because the feature was preview when I recorded, I have to send some preview headers. So that's why I'm trying to do here is, hey, I want to add an add-on, which is, we call it as confcom, which is confidential computing. You need to have that preview for this to work. Once you add, we expose the drivers that are needed for your confidential containers to launch. We also expose the EPC memory, because as I said, Kubernetes is not aware of EPC memory. So you have to manage this, how you want to allocate EPC memory per application so that you don't overrun and get penalized because of paging that may happen if you go over, right? So this allows you for both the functionality. So in that command, what you saw here was installing the plugin. And once you install the plugin, you should see two of these daemon sets running, and the daemon sets only run on SGX based nodes. I had a typical Python web application here, right? It's running on a standard node on the same AKS cluster, right? And this was a REST API that takes in a value and gives a random value output. Right? Think of this, right? It could be something complicated later on, which performs some cryptography operations or encrypts this with a special key that only happens there. This is my Python application here. Very simple. It just starts a Py file, and Py file has just a REST endpoint which takes in JSON input and returns a JSON output. And I use a NumPy package for some basic math or calculations. This demo is also available on the samples piece, and I will leave a link to this. All right, so all of these remain the same. So I'm going to go over and show you how the confidential part looks like. For a YAML, for a deployment person, it's just another different container. OK, and you're doing a volume mount, but you don't have to do the volume mount anymore because we have the plugin that exposes. What you need, I just want to stop here. You see it is like limits Kubernetes EPC memory EIB 5 MB, right? This allows you to manage EPC memory, and this is what the plugin is giving you, right? And in this YAML itself, you can choose where obviously you can do a node selector or tainting. to land this exactly on the node pool you want. If you don't taint, you just say land this on with an SGX EPC memory. Automatically, the workloads lands on a SGX node because those are the only ones that can say to Kubernetes that I have EPC memory, I can take the workloads. OK, I'm bringing Fortanix in the picture here. So Fortanix is another solution provider for who does amazing things. I'm showing their portal experience here. You could as well do this with their APIs and CLI. I give my regular container and Fortanix spits out a SGX ready container. It's as simple as that. Right, so this is the process. I'm going through this and it returns. Once I do this, it returns me another container and it goes and drops that SGX ready container in the container registry. And I deployed that and I showed you the YAML before. And let's quickly go over what that looks like. This is the SGX path, and if you see how it's mounted the SGX drives, and it's loaded a different image from another registry that is SGX ready. And the end of it is like when I do a HTTP post, it does the same thing, right? It's exact same thing, but now it's running confidentially with your data protected. That's the difference. So this is the lift and shift story to our confidential containers. Just to summarize this, lift and shift, this is what we saw with a typical microservice. You could also use a prepackaged software like Redis, Memcache, Nginx. All of those run on as a confidential container. All right, so I'll go back to my demo again. Sorry, my slides. A few more to finish. I should have started from the earlier one. OK, so I have a few more slides, and I wanted to talk about the additional services we offer that really help you. So Microsoft Azure Attestation, I went out of the presentation mode. Apologies. I didn't want to mess with the timing. So Microsoft Azure Attestation, this is one concept I wanted to bring up again. So what you're doing here is you are attesting the hardware components, and you can also attest the software components. Here is the hash value of my application that was supposed to run. And the party here could be your another native client who wants to exchange data with this, or it could be another service like Azure Key Vault or KMS services that will understand and parse the attestation token. Right. This is a critical component or a backbone to your confidential containers, or generally in the world of confidential computing. Right. And this party is this service is Azure service that you can rely on it, and it goes back, the checks the root of trust back to Intel from the certificate store that when you launch an enclave and ask for the evidence, they do all of that for you, and they issue a token. And this is a standard Java Web Token, JWT, and you take that and you parse that to your third parties to say, hey, parse this and see if everything matches. If it is, then you're good to go and start transmitting the data. Important concept. So another important thing here is the Key Vault, right? So as I said, the managed HSM, which is the newer service we have in Azure Key Vault, runs on this confidential computing hardware. So the keys and the backend and the front end that is used, it's all confidential computing and attested. So we, as a PaaS service, we continue to do this. We have other services around the space that are all built on top of confidential computing hardware. As I said, AKS nodes that is going GA as we speak. We have SQL that's in public preview with SQL always encrypted with secure enclaves. This is for your relational database management and how you want to bring that into the picture. At the end of the day, the confidentiality doesn't have to stop in your compute layer. It goes beyond it. It's beyond your application. It's a full application, right? So that's why we are lighting up all of these full stack of applications that allow you to bring your whole scenario and run your scenario confidentially, right? Like backend database is one of them. Key management is critical. That's how we're lighting up. And another service what we continue to see is the ML space, right? A lot of ML training and ML inferencing is a place where API information is very common. So we built a Onyx based custom runtime for you to bring in your trained ML models. It could be TensorFlow, Keras, or any of those, convert them into an Onyx model and run them confidentially using Onyx open source runtime. And when you run that, it packages as a container and you can take it and run it on Kubernetes if you would like to. Right, that's another service that is in beta. Another last service I wanted to bring up is the Azure Confidential Ledger. This is a net new service that went private preview. This is about the auditability and write once, like tamper-proof logging. Right, we know how important these apps are, and the auditing and meeting those regulatory requirements are super critical. So this service allows you to log all of this, log once, never tampered, right? And it uses a backend blockchain-based confidential computing framework, which is an open source project. And this service is built on top of Kubernetes as well. So this is an attribute to do the work about how we in Microsoft take the same product and to run our services, and how our customers also take the same product and run their services in production. Right. This goes back to the confidential container. So this is the start. We have much more services to help out light up your end-to-end scenario. You can reach out to us, and here I will leave some links for you folks. You can directly reach out to the product team by using this email, acconaks@microsoft.com. The emails will come to me and some of my partners who can help you answer the questions. For the samples, you can go to ACC architectures. We have the sample I spoke about, where you have the hospital and the provider. That sample is fully open sourced. And I have another Azure samples repo from the docs page. It links back to that goes into details about a Python app or other common scenarios we have seen. Confidential containers, you can also build what we call as enclave aware containers. Okay, two terminologies. I have separate pages on docs that will go over what that process may look like and how we support that on Kubernetes service. And generally anything about confidential computing, the value proposition, and how the technology works, you can go to the first page, Azure Confidential Computing. So this is my last slide. This was an introduction, and hopefully we'll plan to have more deep dives based on the feedback we see for today's session. With that, I want to open up for any questions.
Great, Amar, thank you. Although the team has been answering the questions coming in through the IM, I wanted to check here with Graham if he has anything additional to share with us.
Yeah, I think a couple container-specific questions that came up in the chat would be good to expand on a little bit, Amar. There's a question around just the image signing and how to assert the integrity and signing of the image, and if it's only signed images that land in the containers. So maybe a little bit more on the container signing process. And as well, we just had one come in at the end around a little bit more on how the attestation is done and checking the integrity of the Docker image. So I know some of that was in the demo that didn't get to be completely covered. So maybe you could just expand a little bit verbally at the end here.
Yeah. So the first question about the container signing process, right? So the regular container signing process through Azure Container Registry plus the current process we have, that's one way of you leveraging that feature. Confidential computing does not have a layer of additional signature checks we do, right? That layer is at the Containerd runtime and the Kubernetes. The new project, which is Project Notary V2, which obviously we are working towards in our services to light that up, will allow you to have custom signatures and the signature validations at the runtime, right? That's one layer. So the another layer, what I was talking about is when you want to have a custom signature, that signature, you can also upload that signature back to your Azure attestation, right? So when you do that, the attestation is checking for that signature before attesting anything, and also checking for the integrity of that code, which is kind of asking you, hey, what's your hash? Right, and this was the hash I was expecting it to be. And if it matches, then I attest you. I say, yes, you are who you are, and you are good to go. And the container that's being launched matches what it is. So that's how the attestation adds to this layer. Just as a regular container signing process does not directly interact, but however, there's a partner like Scone who has approached this differently. They take a different approach because of they encrypt the container itself, which is a layer above your signature. Once you encrypt the container, the keys that are used for decrypting is only made available to that application through a policy management, right? So you put a policy in place, decrypt me, and that's how you launch the application. Because before that, the key release orchestration that needs to happen is fully tightly controlled through the policy management and the hash value, or what we call as MR enclave details that needs to match. So that provides the code integrity part to it. And there is ongoing checks from that software that happens to see if there is any tampering or any change that was not supposed to happen. If that breaks the integrity, the application stop, and they report back saying there is something that I cannot, I feel is suspicious, and the integrity is tampered. So different products do that, but AKS with confidential computing nodes by default does not check for your container registry keys you are signing. The attestation provider, the MAA in this case, does it. I hope it answers your question.
Perfect. Yeah. Thanks. And then, sorry, Valon, just what's the time check?
We're doing great on time. We have 5 more minutes, so if you have anything else to share, please go ahead.
Yeah, I think a couple more things. Amr, in the chat, there were a couple questions on just the memory and performance, just with what's available today, and then we answered in the chat as to what's coming. Do you have any further comments in terms of typical applications that we've seen in Kubernetes today, and any notable performance differences? Yep.
So the largest EPC memory as we speak is 168 MB. And you may raise your eyebrows on 168 MB sounds very small, but here's the fact, right? Once you load your container, only at the container launch time, right, when it's booting up and pulling all the binaries down and expanding the binaries, loading them up, is when you see some performance blimp, right? After your application is fully loaded, it's all about how much data it can cache and process. The current state of my customers who are in this space, they have very less performance related questions. They're building these data processing pipelines that run for days, right? These are not low latency requirements. For them, we are able to give what they need. But we are obviously investing in the next set of hardware that will bring you a lot more memory to bring your very less performance penalty type of applications that you need to run. So generally, you see only a blimp when the application is loading, and once it's loaded, you should see very less notable performance, is how I have seen based on the current services the customers are running.
Perfect. And yeah, and we did note in the chat the next generation that Amr was referring to is the Intel 3rd gen Xenon scalable processor, and that expands more than, it's multiple thousand times of what we have today, up to hundreds of gigabytes of encrypted memory. So in the near term future, we'll be able to have servers with much more expanded memory to be able to take on any enterprise and low latency type applications. So very, very encouraging and excited there.
Yep.
And Amr, I know we have other services on Azure that run on confidential computing and we're ever growing. So can you just give some perspective on how solutions can leverage? You introduced a couple there in those slides. So just can you expand on how solutions can leverage some of these multiple services that are coming out on Azure?
Yeah, I think starting with, as I said, right, SQL is a great add to this family of Azure Confidential Cloud services. We always see the data process needs to go somewhere. So what we have seen is, right, so the key thing with any customers have spoken to till now, and I've been working actively for past 6 or 8 months, they have a need for a key management. They have a need for attestation. So those are 2 services. They start seeing a need for a ledger because they want to make sure the logs end up in the right place and never tampered, so they can meet their regulations. And SQL is getting added to this service. Obviously, this does not stop us. There's plenty of opportunities we are looking into, and we want to hear from you. Where do you want to go? Where do you want us to invest to solve your business problems? Do you see more value of this in the data and AI space from the data analytics type of scenarios against if you see more of an edge cases, right? We also have IoT edge enclaves. We want to protect the edge as well. So we have services in the IoT space that also cover around the edge confidentiality and edge protections and edge attestation, all 3 included. Obviously there is a like a hybrid type of approach, right? You start here, but you still have access to your like an Azure Arc integration and things around that space. We are obviously looking into to expand further. So if that answers your question.
Yeah, absolutely, and it's just great to reference where we're not stopping at just the infrastructure and the container deployment.
Yep.
Azure's fully invested in more data protection across our first-party services as well. So,
yep.
So thanks for the reference there.
And this is a session you need to tell us where you want us to solve your business problems and where do you see a need. Serverless container compute to VM compute to databases to data analytics space or ML space. Where are your business problems? Let us know, and we are here to invest and make your life easy. One thing I wanted to call out, which is back to the other question about EPC memory management, right? Once we have a lot more EPC memory, we are actively working with the cloud native and Kubernetes projects to see how do we make EPC memory a first-class monitoring, scheduling resource on Kubernetes. Right now, you can manage CPU and regular memory. Tomorrow, you may be managing your EPC memory in the same way. So we want to bring that up, that metrics up into that layer as well. So if you are a cloud native, if you are a developer there in that space, we would love to involve and solve this problem across the board. It helps us do everything in the open.
Well, great. This has been great. Before we close, just wanted to remind folks who are still on the line that tomorrow we'll be hosting a webinar session on accelerating your Azure Sentinel deployment with all-in-one accelerator. And for those of you who has not joined yet, and for details and registrations, please visit us on aka.ms/security-webinars. In case we missed to answer your question, we already posted on the IAM an email account that goes to the product-related questions, but also feel free to reach out Azure Compute Forum. This is on Tech Community at aka.ms/Azure Compute Community. And I would like to close this webinar by thanking Amr for an excellent presentation, and thank you, Graham, and to the rest of the team who helped answering the questions. And most of all, I want to thank all of you for being part of our community and for joining us on these webinars. And we hope to see you next time. Goodbye.